Okay, in this lesson we were looking at patterns. By the end of the lesson you should be able to find a pattern derived from a diagram and also generate sequences from a diagram. Okay, let's have a look at the first example. Number patterns, matches. Okay, so Garrett uses matches to produce hexagon patterns. If you look at the first pattern, it's just one hexagon, so this makes up pattern 1. Now, for the next pattern, there will be 2 hexagons. This makes up pattern 2. Now, for pattern 3, you would have 3 hexagons. This would make up pattern 3, like so. Now, if I was to draw out pattern 4, yes, you have guessed right that there would be 4 hexagons to make up the pattern 4. Okay, so what I would like you to do now is have a go at a rough sketch of pattern 5. Pause the video here and we should go back in a moment. Okay, so for pattern 5 you should have written down at least 5 hexagons, like so. This will drive up the pattern for pattern 5. Okay, here is a pattern of circles. First question, draw the next pattern in this sequence. To draw the next pattern in this sequence, I'll have to draw out the previous pattern first. So, if I copy the previous pattern out, I have the same diagram shown, and as you can see that on each of the previous patterns a circle is added on at either end of the diagram. So to get the next pattern in this sequence, all I have to do is add a circle on either end of the previous pattern. Let's have a look at the second question. How many circles are there in each pattern? That is quite simple. All you have to do is count. So the first one is 3, the second one is 5, third one is 7, and the last one that we just drawn out now has 9 circles. Okay, so work out the end term for this number pattern. As you can see, you have your number pattern 3, 5, 7 and 9. To do this, you need to work out the end term rule using the DNO method. Remember, D is the difference, so the difference is of each term is plus 2, plus 2, plus 2, so the difference is 2. Now the n keep the same. The 0th term is therefore, that's your first term. To work out your 0th term, you'd have to go back. Okay, so if you're plusing 2 to find the next pattern, to find the previous one you must minus 2. That will give me a positive 1. Okay, so my 0th term is plus 1. Therefore, to work out the end term of this expression, for this pattern, is 2n plus 1. Right, how many circles are in the 10th pattern? Now to work out how many circles are in the 10th pattern, there's 2 ways you can do it. First, you can sketch them out until you get to the 10th pattern, or you can simply use the end term expression. So you do when n equals 10, substitute this in to our end term expression. 2 times 10 plus 1. So 2 times 10 is 20 plus 1 is 21. Therefore, there will be 21 circles. Okay, what we'd like to do now is have a go at the following question and pause the video here and have a go. Okay, so to draw the next pattern in the sequence, it is thus. This is the next pattern in the sequence. How many lines are there in each pattern? Hopefully this should be have done 3, 5, 7 and 9. Work out the end term for the rule for this number pattern. The end term is 2n plus 1. Okay, so this task is now separated into 2 slides, so please have a look at the second slide. This is the second slide. Please have a go at this slide as well, and please upload your answers to ClassCharts.